In section 8.6, we're going to try to put everything together and see how we can do with these properties. So remember, let's go through our hierarchy again, guys. So quadrilaterals, remember, are four-sided shapes, right? Quad means four. So we've got our four-sided shapes. And this is just a different way to help you kind of organize yourself. So hierarchy, you've heard me talk about, but we have quadrilaterals, which are all four-sided shapes. And then we had this part of the hierarchy where we had parallelograms. And remember, a specific type of parallelogram was a rectangle. Another specific type of parallelogram was a rhombus. And then a specific type of parallelogram, rectangle, and rhombus was called a square. And then we'll just do a different color here because they were not related, but they were still four-sided shapes. Then we also had trapezoids and a specific type of trapezoid called an isosceles trapezoid. Okay, so that's how we've looked at it so far. Now, a Venn diagram, in case it helps you with the next problems that we're doing, this would be a little bit different. So this would say, well, just like you see over here with this, that there's some overlap with rectangles and rhombi. They overlap in a square. So I'm going to start smaller and get bigger. So let's say this circle represents rectangles. And this circle represents rhombi. And where they overlap, you would have a small s in here for squares. And then all of them are parallelograms, which I will just abbreviate. Then over here, you would have a specific type of trapezoid called an isosceles trapezoid. And it would be encompassed in a circle just called trapezoids. And then if I were to outline all of them, if I were to outline all of them, they would all be quadrilaterals. So these different hierarchies or Venn diagrams might be useful with the stuff that we're coming up to next. Okay, so try coming back to them and using them and seeing how it works. All right, so for these problems, true or false? If it's false, change the statement to make it true. We'll have to practice like which words, when we give them to you on a quiz or a test, we'll probably underline the word that we want you to change specifically, but let's practice here. So number one, all squares are rectangles. So you might go back and look at this picture and say, well, a square down here is under the rectangle. So that would be a true statement. Number two, every trapezoid is an isosceles trapezoid. Well, that's not true. Isosceles is a specific type. Okay, you can also tell in the Venn diagram that some trapezoids inside are isosceles trapezoids. So that's actually just in reverse. So you would say false, and then they want you to change it so that it's true. So here's what we're going to change. We're going to say every isosceles trapezoid is a trapezoid. So if I take that out and reverse it, now all of a sudden it's true. So if a quadrilateral is a rhombus, then it is a parallelogram for number 3. So again, I don't have to read it to myself. If a quadrilateral, so a four-sided shape, is a rhombus, then it's a parallelogram. So looking back here, if it's a rhombus, then it's a parallelogram. Of course, it goes that way. It goes up. A rhombus is a parallelogram, is a quadrilateral. Okay, so that would be a true statement. Some rectangles are squares. And then again, you can see where we're going with this. Some rectangles are more specifically called squares. So going down, that is definitely true. All right, number 5, all quadrilaterals with 4 equal sides are squares. So in this one, you want to think about where the first time is you ran into that property. Where's the first quadrilateral that had 4 equal sides? So the first time you had 4 equal sides, it was a rhombus. But this says all quadrilaterals with 4 equal sides are squares, and that's not true, okay? So the first time you came into it was a rhombus, so you're going to say this one's false. They're not all squares, but they are all, we'll cross that out and change it to rhombi, which is just plural of rhombus. All right, number 6, if a quadrilateral has 4 right angles, again, you want to start thinking about where's the first time you ran into that property, then it is a parallelogram. Okay, now first people's instinct is to say false because parallelograms don't have right angles. That's not what it's asking you. It says if a 4-sided shape has 4 right angles, then it is a parallelogram. Now, if it has 4 right angles, the first time you run into that is a rectangle, right? Looking here. But is a rectangle a parallelogram? Yes. So that's what's going to make it true. They also said that they also could have said it's a quadrilateral. That's also true. A rectangle is a parallelogram. It's also a quadrilateral. So this one is most definitely true. Okay, so use those Venn diagrams or hierarchies to see if they will help you to master these true-false type of questions. The next type of questions you have to be ready for are as follows. So from here on out, all of your pictures are going to look like this. Okay, whether it is a parallelogram, a rectangle, a trapezoid, an isosceles trapezoid, a square, or a rhombus. This is where we keep saying you have to know your properties. So make sure that you do write down what I'm writing in the pictures very carefully. Okay, so for number 1, let's say these were the markings. If you saw that, then the property you should write for yourself, this would be like the showing the work or what you're thinking, is you would be saying that those 4 marks means all sides are equal. And the first time, you want to be as specific as possible without being totally specific, but as specific as possible down the hierarchy is what I mean by that. The first time you ran into all sides being equal was a rhombus. So you can say this is a rhombus, but you can't go as far as saying that this is a square. More things would have to happen, such as like right angles in the corner or so on and so forth. All right, number 2. What if this was in the picture? All you saw were those arrows. Well, then you want to think of this as saying one pair of parallel sides. Okay, so I can't make the assumption about the other set, if there's another set or not. So one pair of parallel sides takes me out of the parallelogram hierarchy. And that puts me in a trapezoid because those would be the 2 bases that would be parallel to each other. So again, I'm going to do about 6 more of these. I highly suggest that after I draw the picture, you turn off the video and you try to ask yourself, what's the property and what would the shape be that you would have to name? And then come back and see if you're correct. All right, so for number 3, here's what we should put in the markings. Okay. So first of all four of those parts being equal, all four of those parts in the diagonal, would first of all mean that the diagonals would be bisecting each other, but it would also mean if all four marks are the same, the diagonals must be equal in length. Okay, so here's the properties you're trying to think of. Diagonals bisect each other. And the diagonals are equal in length. And the very first place that the diagonals are equal in length, remember that happens when a shape is uprighted, means it must have some right angles as well, would be a rectangle. Okay, number 4. Here's the markings. Put single marks there and double marks there if you want to go off and try it yourself. All right, so all I am noticing there is that this means opposite sides are equal. And the very first time that you came into contact with a shape that had opposite sides equal was a parallelogram. Okay, we wrote that over and over for days, but there's the first place it came into play. Okay, now I want to practice 4 more. So go somewhere you've got room and draw these 4 again. So draw a square for 5, 6, 7, and 8. And then here we go, continuing with our practice. For 5, let's draw 1 set of arrows, 2 set of arrows. Okay, you can try it yourself. So these would mean the property I'm looking for is 2 pairs of parallel sides. 2 pairs of parallel sides. All right, the first place you saw 2 pairs of parallel sides, once again, was a parallelogram. You can't be any more specific than that. Again, it's the first place it shows up. All right, for number 6, let's put those markings and those markings. All right, so notice what those markings are telling us. We have 2 angles next to each other at the top that are equal. 2 angles next to each other at the bottom. The key is that they're next to each other because this picture could be turned. So turn it 180 degrees or even turn it 90 degrees, doesn't matter. Either way, you've got to recognize that since 2 of them are together, what I'm really looking at is like upper base angles and lower base angles. So if upper base angles, UBAs, and lower base angles, LBAs, are equal, the first time that happens is in an isosceles trapezoid. So you can tell me isosceles trap for abbreviated. Okay, but don't abbreviate it any further than that. Isos trap. All right, next one, let's get a little more specific. Let's put single marks here, double marks here, and that box. All right, so we've got a few things going on here. So first thing I'm noticing, based on the 4 different marks on the outside, I'm noticing the diagonals are bisecting each other. So think about the first time that happened. But there's an and this is happening. This is meaning the diagonals are meeting at right angles, so the diagonals are perpendicular. So now we're trying to figure out where's the first place that I had diagonals bisect each other. And that the diagonals were perpendicular. And the first place that happened, hopefully you're thinking, is a rhombus. Remember, anytime you see diagonals in a rhombus, the very first thing you should do is draw in the right angles in the middle. All right, last one here. Let's practice this one. Okay, and put that box there. Now, similar to number 1, right? We had all sides equal. Here's the difference though. Here we have all sides equal. But there's an and statement. And this right here is telling me I have right angles. So adding that piece of having the right angles changes it from number 1, when it was a rhombus, down to a more specific type of rhombus called a square. Okay. All right, so putting it all together, here's what's going to happen then. Again, we've got this shape that just sort of looks like a square or a rectangle or something like that. They're all going to look like this. So let's put some letters in here just so that you and I can talk about it a little bit easier. Let's just make this quadrilateral ABCD. And we'll use the information that they're giving us. We're going to identify the quadrilateral, solve for x, and find the indicated measurements. Okay, so here we go. Angle A, I'm going to go ahead and write in what it's giving me. 10x plus 6. Angle C, 2x plus 30. And there we go. Okay, so I'm just going to go with the markings first of all and start figuring out what this thing is. So in the markings, see if I can get that to look a little better. I noticed that I have one set of parallel sides based on the arrows that are here. So one set of parallel sides. And I noticed that I have these two angles next to each other marked equal. So those must be upper base or lower base angles. It really doesn't matter which one you think it is. I'll just call them upper base angles that are equal. So those two pieces of information leads me to the fact that this is an isosceles trapezoid. Okay, so identifying the quadrilateral, the answer would be isostrap. Now using isosceles trapezoid properties only, I will figure out what I'm going to do to solve for x. Okay. Now, since these are marked the same, I'll go ahead and change colors. Since these are marked the same, I'll go ahead and call this 10x plus 6. And in an isosceles trapezoid, I know that any upper base angle and any lower base angle are supplementary. Okay, but I kind of moved it over there so that you could see this backwards C going on here. Okay, and you know that the angles inside of a C are supplementary. So we'll say that 10x plus 6 plus 2x plus 30 equals 180. And go ahead and solve. So 12x plus 36 equals 180. If we subtract 36, 12x would be 144. Divide by 12, x is 12. They did ask us to find x, so there we go. There's that part. And then it also asked us to find angle B. So angle B equals angle A. Remember, your work should sort of explain what you're thinking. And therefore, you're going to plug in x into the 10 times x, so 10 times 12 plus 6. And therefore, angle B would equal 120 plus 6, so 126, and it's an angle, so make sure that you put degrees. And there you have it. All right, good luck. Keep practicing with those properties and seeing what you can do with this.